Hello everyone. So are you confused with which book to follow for Olympiad geometry and which book to follow for advanced geometry and fundamental geometry? So here is a book that we are going to discuss today about Euclidean geometry for math Olympiads. So the name of the book is the same, Euclidean Geometry for Math Olympiads by Chen. This book is helpful for kids who are preparing for Olympiads like IOQM, RMO, INMO, and AIME, USAMO. So this covers some advanced geometry concepts, and the problems are really interesting and they are quite intricate. And it's a diverse set of collection of problems. We will get a closer look towards the contents of this book and we will learn from it. So here are the contents of this book. It majorly has 4 sections, starting with fundamentals of Euclidean geometry, and the second section is the analytical techniques involving methods to bash a problem, and third section is named as farther from consensus. So this might be a little deceiving topic, but it just means that they are providing some advanced techniques and transformations of the plane in order to tackle some problem easily. So there is a small section as the 4th section of this book called as appendices that involves hints and solutions to selected problems. Let's come to the first section. First section has fundamentals of Euclidean geometry like angle chasing methods and circles and the Linson ratios and some configurations as given here. So these are very important tools for solving problems, though these tools are not necessary for each and every problem, but they will be really helpful for many problems that are difficult. Also notice that there is a section named as problems under each of these sections. So they denote a heterogeneous collection of math Olympiad problems all over the world, which are harder than AMC or IOQM level problems, but easier than the international math Olympiad problems. They are intermediate between those two. And the tools that you study in this book will be really helpful to tackle those problems. They are chosen or handpicked in that way. And an important point to notice is that each of these problems are associated with several hints, and at least 2 to 3 hints are provided for each. And they can be referred to the 4th section as we discussed. And solutions to selected problems are available at the end as well. As the second section, we have analytical techniques, which are the bashing techniques to solve geometry problems. For example, we have computational geometry, which involves trigonometry to solve a particular problem. And complex numbers is an amazing topic. You might be baffled why this complex number is present in a book for geometry, right? So complex numbers are essentially numbers that represent points on the plane, and geometry are nothing but figures that are constructed on the 2-dimensional plane. So now these two combine in this way and give a beautiful conjunction of algebra and geometry. So you can go through this chapter to learn how algebra and geometry work together. Complex number is a very important tool to tackle problems in geometry. And then we have barycentric coordinates, which talks about representing a point with respect to a triangle, with respect to vertices of the triangle. So it is like the point Moss theorem that we study in mathematics. So you can also use this for solving some problems. And next, we have the section named farther from consensus. So as I told, these are some beautiful transformations of the plane that help you solve the problems easily, which you might think is very difficult with the usual Euclidean geometry techniques that we had studied till now. For example, inversion is there. Inversion is performed about a circle, and it transforms lines to circles and circles to lines and so on and so forth. And it can make difficult looking diagram to a simple looking diagram to analyze. But sometimes do note that it can make simple looking diagram look more complicated. So you have to be selective in that regard. So again, practicing problems will make you a master in the respective concept. And then comes one of the most important tools in Euclidean geometry called as projective geometry. So this is about preserving the cross ratio of 4 points. Cross ratios are defined for 4 collinear points, 4 concyclic points, and so on, and even 4 concurrent lines. So learning projective geometry is crucial because one can even apply this concept outside of Euclidean geometry. So this gives the basics of projective geometry and how to apply them in Olympiad style problems. So again, there are several subtopics in the projective geometry. You can go through them. We have the next subsection as complete quadrilaterals. It is about extending the sides of quadrilateral to intersect outside the quadrilateral or inside it. And we analyze them about the circles, the circumcircles, and a point that exists which is on every circumcircle of the 4 triangles that you consider in this. So there are a lot of beautiful properties you can read from this chapter. So then we have the appendices, which is the 4th small subsection. Appendices is the 4th small section. You have some subsections on linear algebra, and the second subsection on hence, third one on selected solutions. So hence is provided for all the problems in the previous 3 sections, but solutions are provided only for selected problems, which is mentioned. And then we have the last subsection as list of contests and abbreviations. So if you're confused with the abbreviations provided, please refer to this appendix D or the 4th subsection of appendices to get it clarified. And then we have bibliography, the references of the author and the index, and some description about the author. Let me show you a question from this. For example, you have problems for each subsection that we saw. In angle chasing, triangles and circles are the fundamentals or the foundation of it, and there are some problems provided to consolidate your understanding in this topic. So this problem also comes along with hints, and again some solutions are provided if it's mentioned. So the hint number for this problem is 185, so which means you have to navigate to the 4th section appendices and go to the 185th hint and refer to it. And over here we have 2 such hints, and then we have the subsection cyclic quadrilaterals, and we have 2 problems in it. So after working out on dedicated problems for each subsection, you can go to the collection of overall problems for the entire section on angle chasing, which is provided by the named problems. This is what we were talking about earlier. So for example, here you were given around 18 problems, and some are from IMO, USAMO, and some are from Canadian Olympiads, and some are from Russian Olympiads. So it's basically a heterogeneous collection of problems. For example, if you are confused with BAMO, the full form of BAMO, then you can navigate to the list of contests in the appendices section and get it clarified. And here are the hints provided. So you have to go to the hints in appendices. And here is an example of a selected problem for solution. So here you have solution on page number 241. So you can directly go to the page 241 and refer to the solution. So this is how you have to keep on learning the concepts and solving the problems. And if you do it regularly, you will be able to learn a lot after several months. So I hope this will be really helpful for you. See you all in the next book review video. So keep on learning good mathematics. Thank you. Bye.